Welcome to Altair Engineering Training and Support. Today, in this training series, I am going to discuss few points. So, let's start with the introduction. In this training series, I am going to discuss about the SolidThinking Inspire 9.5. I am Apoorv Bapat, working with Altair Engineering. So, the training this training ST Inspire 9.5 training series schedule will be as: first I will show you how to apply for the license of SolidThinking Inspire, then I will show you how to download and install SolidThinking Inspire on your machine, and how to activate the license of ST Inspire 9.5, then the basic operations of SolidThinking Inspire 9.5, modeling operations of SolidThinking 9.5, optimization operations of SolidThinking Inspire 9.5. Then we'll see some tutorials like getting started, moving and snapping, sketching and optimizing a bridge, then exploring multiple load cases, preparing CAD geometries, defeaturing a model, minimizing mass, saving and exporting file. So today I am going to show you how to apply for the license of SolidThinking Inspire. Today is the day 1. So open the internet browsers, anything like Google Chrome, Mozilla Firefox, Internet Explorer, whatever browser you use, open it. Open the Google search and type there Altair store. So a website will open. Before we go further, just click on this website, that is https://secure.altair.com online store. So before I proceed further, first I want to mention a point that those who have the license of HyperWorks Student Edition version 12.0 should not apply for the license of ST Inspire or Evolve, because the same license file will work for the ST Inspire Evolve. So those who have the license of HyperWorks Student Edition version 12, just go to the next video and see how to download and install the software, and then how to activate it. So those who don't have the license of HyperWorks Student Edition version 12.0 can continue in this video and see the process how to apply for the license of HyperWorks Student Edition. So the first step is select the country and click on login. Once you click on login, it will redirect you to a new page of store home login. Here you need to create an account. It's good if you provide these details, but generally it's the star mark details which are required. So I will enter these, like then in the country, first select India, then enter the state and the zip code. Enter the email address, again the same email address as the confirmation, telephone number, login ID. I will it's a general suggestion that create as simple as possible login ID and password, because you are creating this account just to apply for the license, and once the license will get approved, to download the license. Apart from that, and also to download the software setup. So apart from that, these three things, there is no use of this login ID. So make it as simple as possible, so that there is no chance of forgetting that. So I will have the ST Inspire as the, I'll make it as ST Inspire, or I will have Apoorv ST Inspire. You can use any one, or I will make it more simpler as and password. Make the password very simple. Whether you want to get the newsletters and email details, so make this tick, or you can untick that also, and enter the word verification as EB7. Click submit. Oh, there is an issue with the street address. And the city. So once you click on submit, it will redirect you to a next page, that is your account has been created. Now you have to activate it. So to activate this, you will get an activation code on the mail ID which you have provided earlier. So you have to open that mail ID. So you can see that I have got a mail as from the Altair Store account activation as a subject. So I will copy this activation code and paste it here. Just click on submit. So email is validated, your account is now active. You can see it here. So my account is active now. Now I will show you how to apply for the license. So click on HyperWorks Student Edition Annual License. It will ask you to provide the Ethernet host ID. It's my general suggestion that enter the Ethernet host ID which is available in the command prompt, instead of click here to download and run the tool to find the Ethernet host ID and paste it below. Instead of using this, I will show you the different process to get the Ethernet host ID. So to get the Ethernet host ID, press window key R. I will again repeat, press window key and R to open the run command and type CMD. Open the run command and type CMD. It will open a command window. In that command window, type IP CONFIG \all. I will again repeat, in that command window, type IP CONFIG \all and press enter. Once you press enter, it will show you all the Ethernet adapter physical connections and everything for your machine. You have to enter Ethernet adapter local area connection. The Ethernet adapter local area connection physical address, without these dash, you have to just provide that alphanumeric number directly to this. It has to be of 12 digit. If it's 00000E0, your license will not work. So if you are getting here 0000E0, that means the LAN drivers are not installed. So first you have to install the LAN drivers and then you can run the same command, window key R, type CMD to open the command window, then type IP CONFIG \all and press enter, and then you can see Ethernet adapter local area connection physical address. So my physical address is B8AC, so I will type it here. So it's already there. I will just cross check. B8AC 6F CC 2E 1F. So it's correct. Then I will click on add to cart. Once you click on add to cart, it will redirect you to a new page, that is store home shopping cart. Then click on checkout. Oh, it again redirect you to here. Oh, no issues. HyperWorks Student Edition Annual License B8AC CC2E1F, add to cart, checkout. Just click on checkout. If you got the coupon code from our side, you can enter the coupon code here. Otherwise, you can directly click continue checkout. You don't have to pay anything to get this license. It's free for students. And once you enter to the step 3, just click on place order. So in this way, you have successfully applied for the license of HyperWorks Student Edition, and your order number is 15730. Once you apply for the license of HyperWorks Student Edition, you will get a mail asking for some details regarding the student edition. Once you provide these details, your license will get approved. Just go through the next videos to see what happens when the license gets approved, how to install the software and download the software, how to activate the license also. Till that, I have covered how to apply for the license of SolidThinking Inspire 9.5. Now in this video, I am going to show you how to download and install SolidThinking Inspire 9.5 on your machine. So open the browser which we have opened for the license application process. Open the same web page as secure.altair.com online store, or type on Google and search Altair store. The first link will come is this. Now I'll just log out to show you again how you can log in. So just click on login. Enter the login name which we have created in the last step, that is Apoorv Inspire, and enter the password. Press enter or click on login to login. So this is your account information. In this you can see that my date of the license, my order number, the name, and delivery is, you can see as the status is delivered. But sometime what happens is in your window it will come as pending. So if it's coming as pending, that means your license has not been generated by us. So you can write us back by providing your 5-digit order number, that is my order number is 15730. In the same way you will find yours here. So write us back with the order number and check with us why your license is not generated. So now my license is as generated, so I will not show you the activation process here. I will show you the download and install process of the software. If it's pending and it's delivered, it hardly matters. You can still download and install the setup. So now click on Student Edition Download. Once you click on Student Edition Download, you will redirect to a new page, that is Store Home HyperWorks Download. In that, select the software download Altair HyperWorks Student Edition. In this, select SolidThinking Student Edition 9.5. You just click. If you are using Google Chrome, just click, it will start download. If you are using any other software, you can download it by like save as link and other way of downloading. It's simple to download. So now as you can see, my software has been downloaded. So now I will double click here. So before double clicking on or before opening it, I will make sure that it's ST 9.5 HW 12.0 edu_win64en. The total file size is 837 MB. So just double click here. It will start the it will ask for user account, the permission to make the changes to this computer. So just click yes, and it will start the install anywhere. So install anywhere means it's extracting the setup file. The same setup will help us to install SolidThinking Inspire as well as SolidThinking Evolve, and the same license file you can use for both the softwares. So actually if you have applied for HyperWorks Student Edition version 12.0, the single license file you can use it for HyperWorks products as well as SolidThinking products. So the single license file will work for both the products. No need to apply for the license again. And if you are applying directly to use ST Inspire and Evolve, you can use the same license file for HyperWorks products. So the single license file will work for all the products. So both the softwares available here can be used by this single file. This Apoorv Student Edition 12.0 and SolidThinking Student Edition 9.5 can be used. So it's extracted. Now it's asking for installer for SolidThinking. So just click next, and now it will show you the license agreement. So select the radio button as I accept the terms of the license agreement. Again click next. I personally suggest that please use the default install location, that is C program files Altair 12 edu SolidThinking 9.5. Click next. It will provide you the pre-installation summary, that is product name, install folder, shortcut folder, disk space information. Click next. It will start the installer. So you can see my installation of SolidThinking 9.5 3389 Student Edition has started. So it will take couple of minutes to install, also depends on the system configuration. To know more about the system configuration, you can have a look on installation guides and overview. So one more thing I want to mention it here: if your license is not activated yet or it's not generated yet and still you are downloading, so you will not find this thing on Student Edition download. So when you open Student Edition download and if you are not finding these things, that means your license is not generated. So for my machine the license is generated, so that's why it's showing here. But if in your machine if it's not showing, that means your license is not generated. So as I earlier told you, feel free to contact us if your license is not generated. So my installation is done. It's saying congratulations, SolidThinking 9.5 3389 Student Edition has been successfully installed to the install location. Press done to exit the installer. Just click done. It's done. So we'll open it. Go to start, all programs, HyperWorks Student Edition, SolidThinking Inspire. So it will open the ST Inspire version 9.5, but it is showing an error, that is license error. So in the next video I will show you how to activate your license. We are back on the same web page, that is https secure.altair.com online store. Same process. Click login to enter to the login page. Enter the login details. Click on login. Once your license is delivered, click on, first you have to check whether the license is delivered or not. Once it's delivered, click on Student Edition downloads. If it's pending, please check with us why the license is still pending and make it delivered. So in Student Edition downloads, in the last column you will find licenses. Click on HyperWorks Student Edition license. It will have the license expiry date. It will download the license. It has, as you can see, my default download directory is this. So it has downloaded the license file as altair_lic. So to activate the license version of ST Inspire and Evolve, I will just copy this and paste it in program files, Altair 12 edu, SolidThinking 9.5, security, and paste. That's it. Once I paste it, it will start working. But still sometimes people find some issues like the license is not working. So the major of the issues will be, I'll tell you that, open the license file in TextPad.
right click, open with Notepad, WordPad or TextPad, whatever program you want, you can open it with that. Here you will find first the version should be 12. The Ethernet ID should match with the physical address in the command prompt. So I will check it. If it's not, then the license will not work. Window key R, press the window key R from the keyboard. It will open the run command. In the run command, we will type CMD to open the command window. In command window, just type ipconfig ipconfig /all. It will open the required configurations of your machine. We will search for the Ethernet adapter local area connection. My physical address of the Ethernet adapter local area connection is B8 AC6FCC 2E1F. So this is exactly same as given in the license file. So my license will definitely work. So I will go to Start, All Programs, HyperWorks Student Edition, SolidThinking Inspire. Once you click on Inspire, it will start the GUI of Inspire. So you can see that my license is working. Earlier, in the earlier video, I was getting an error of the license, but I haven't get now the license error. So my software started working. In this way, you can activate your SolidThinking Inspire as well as Evolve software with the same license file.
In today's session, I am going to show you some basic operations of SolidThinking Inspire 9.5. Then we are going to see the following options like file menus, mouse controls, keyboard shortcuts, workspace, adjusting the views, basic functions, organizing your model, materials, measuring tools, translate and rotate command, show and hide icons, activate and deactivate icons, and view tools. So we'll begin with the ST Inspire GUI. So this is the ST Inspire 9.5 GUI. To open ST Inspire, go to Start, All Programs, Altair HyperWorks Student Edition, SolidThinking 9.5, and click on Inspire. Once you click on Inspire, it will open the GUI like this. So as in this session, I am going to cover some basic operations in ST Inspire. So first we will start with the defining the GUI. So at the top, it's the drop down menus, or you can say the pull down menus, which covers File, Edit, View, Help. These are the icons through which you can access the file menus, lines menus, rectangles, circles, arc, trim and break, push pull, boolean, materials, shape controls, load, displacement constraints, optimization, measures, translate, show, configure and view. This is the model browser. This is the property editor. This is the view controls. This is the display options, grid movements, and the unit systems. This is the model browser. So in today's session, I am going to show you how to use the pull down menus, file options, model browsers, what are there in model browsers, what is there in property editors, the display options, the unit systems, view panel, configure panel, show and hide, translate and rotate, and measures. In the next two sessions, I am going to discuss about the lines, rectangles, circles, arc, trim, break, push, pull, boolean and material. And the next session to that, I am going to show the shape controls, load, displacement, optimization. So let's start with the pull down menus. So we'll start with the file. First option is new, the other one is open, import, save and save as. These five options are as same as any of the software. Then this is the revert option. So whatever you have opened by mistake, you can revert it back. Recent files which you have accessed, you can access it from here directly like this. So this will help to open the last open file. Then exit, edit commands, you can undo the command, redo the command, cut, copy, paste, preferences. View options, view as a full screen, so you can view this as a full screen, no other icons. Then you can turn on and off the model browser, the property editor, the command window, help icons, help, tutorial, what's new, about, Inspire. Then the new model option, these are the three icons in the first tab, that is new model. So as I have already opened the model, so it is asking that your current model has not been saved, so I don't want to save it. So you just click on new, it will have a new window here. Then this, when you highlight this icon, it's a three icons. Once you make your mouse on that, it will highlight. So the open model, you can open these many format files in ST-Inspire, or you can import these many format files in ST-Inspire. So I will select any one and say open. This is the save icon, it will save the existing file. Or if you want to save as or export the file, click on save as. You can export this file into this different format. So I can export it into IGS, say save. So I have exported this into IGS file format. So again I will click and now import the IGS file format. This is the IGS file format I have saved, and select here IGES. Select this file and say open. So this will import the IGS file format. You can see here. Again, this is the model browser, which contains the model information in a tree structure, which contains all the components, load cases, loading conditions, symmetric boundary conditions, optimizations, displacement constraints. In this, if you want to add an assembly or to have an assembly in a component, just click on this icon. It will help you to create a new assembly. And you can move any component in this assembly. So now these two are in this. So if you turn on and off, so this will off and on. You can again move it to back. Now this icon is used to show all the components, hide all the components, show all the components. And this option is for reverse. If you turn off any component, you can reverse it. You can turn on and off any component from here also. Once you click on any component, a property editor option will get highlighted. I will explain you what are the property editor options having. It starts with the general name of the component. You can edit it from here, like any name. I will put it as XYZ. Then you can change the material of the component from here. If you want any other material of the component, you can change it from here. The material you can change it from here also. Just right click material and select any material from the material library. Then you can select that component is a design space or a non-design space. So the design space will go to the optimization analysis, or the non-design space will not go to the optimization analysis. So you can just tick or untick, will make that a design or non-design space. Then mass properties, if the auto calculate mass is on, so it will calculate the mass automatically, or else you can change the mass from here also. So if you want to put any mass higher than what it has already calculated, so you can change it from here, or you can change that to auto calculate. Then the appearances, it has to be visible or not, like mask or unmask. You can change the color. If you want to change the color of the component, you can change it from here also. Then the transparency, if you make it transparent, so you can see this is the model is transparent. 0 means it's not transparent. Then permission, grounded means you cannot move that model to any particular axis. Collision detect collision means it should not collide with the component during the analysis. So that helps for the collision detect if you turn on. So during the analysis, if parts are colliding, it will give a warning. Then the movable, if it's tick, so you can move it, otherwise if it's not tick, you cannot move that model, it's fixed. So whether it's movable or not, you can take it untick like that. Then mesh style, whether you want to auto calculate the element size or you want a specific element size, you can edit it from here. So it will be it will do an backend meshing while it perform the analysis, or you can put it at auto calculate element size. So it will take as per the geometry, it will select the minimum and average element size. Then optimization, auto calculate the thickness, or you can also input the minimum and maximum thickness of the component. Once the analysis is done, the optimization analysis is done. Then the rotate menus, you can first I will show you the mouse controls. Like if you press control and if you press right click and move your mouse, you can rotate the model in the axis like X, Y and Z only. But if you press the center mouse button, the middle mouse button, and move your mouse, you can rotate your model in any direction. It's not specific to the axis. With control, you can move it to a specific axis, not in all directions. But in once you press middle button, you can move it to any direction, not specific to any axis. Then shift and left mouse button and drag will help you to select, and from drag right to left will help to select, and in this way you can select these components directly. These are the fit to screen options. If you have select any object, if you want to highlight that object to the screen, you can use this. This is the orthographic and perspective views. This is the front view along any particular axis. So if your model is something like that, and if you want to align it to particular axis, you can align it like that. You can see it. So it will be aligned to a particular axis or in a plane. Now you can move it. Just press your move your mouse to here. It will keep on rotating and revolving, as you can see. No need to click, just move your mouse from here to here. It will keep on rotating and revolving. So scroll up and scroll down will help you to move, zoom in, zoom out, and shift plus right mouse button will help you to pan the model. This is the grid movement selections, which will help you to align the components with other components. So make sure it's all tick. This option will help you to select the unit system which you want. So whatever unit system you select, everything will changes automatically. So you can see here, it's changing the mass. Now we will see about the preferences options. Rest we are the same as I have discussed. Now we will see about the preferences. So we will start with the workspace. In workspace, the first option is show splash screen at startup. So it will, if you turn off, it will not show the splash screen at the startup. Show icon label. That if you turn off this, apply, so you will not see any labels below the icons. If it's turn on, you can see the labels below these icons, you can see that. Then the theme, you can change the theme of your GUI. Then the language in which you want to see your screen. Then the recent files, how many files you want in the recent folder. Keyboard shortcuts, these are the keyboard shortcuts. Control N for new, Control O for open, import for control, import you can do as Control I, Control S for save, F12 for save as, save selected, Shift F12, exit, Control plus Q. If revert is not there, you can add any like Control A for revert. Then Control A is select also, Control L for revert. Then undo, Control Z, redo, Control Y, cut, Control X, copy, Control C, paste, Control V. If you want for preferences, you can add any. One is for preferences. One is for preferences. It's not taking the number, so let's have Control J for preferences. For full screen, you can enter, press Control Alt F11. You can enter tutorial. For any, you can edit. And to turn on and off model browser, F2, property editor, F3, command F4. Then Inspire modeling space, it will show you the current unit system. You can change it from here also. Orthographic and perspective views. Recovery, whether you want this option to on and off. I suggest keep that option as on, because if it's off and if there is something issue happens in your file, you cannot recover that file. So always make this on. Then the compatibility, if you want the rotate and pan style same as what you have used in HyperWorks tool like in HyperMesh, so you can make it as on. So in the same way you can rotate and pan the model. Or if you off it, so you have to follow the pattern or the style of ST Inspire. Then visualization, that is the edge deviations of between the two components or the two surfaces. Then optimization, in optimization the generally gravity direction is taken as negative Z, so if it's considerable weight of your component and its gravity is placing an order, so you can have the direction of the gravity. If it's your component gravity is not in negative Z direction, you can change it from here. Notify when the run history exceeds the size, yes, always make it as tick. Run history size, make it as 5000. Number of CPUs, you can select it from here, how many number of CPUs you want to run this. Then the run history path, you can edit or change the run history path. Collision detect, as I have shown earlier, that if you turn it all for all the parts, so it will check for all the parts, or if you make it as only parts with detect collision, so you have the option to turn and off. If you press none, so it will not consider any part for the collision detect. Then these are the draw directions options which you can edit, and the mass calculation. If you turn this off, you cannot see the mass here on the model browser, but if you turn it on, you can see the mass of the components here on the model browser. So these are the preferences menus which you can edit. Or if you have added something and you want it to default, so you click on use default, apply and OK. So it will be the default setting. Now we will go with the views from from right to left we will go. So first is the view panel. This is the front view. Just click front, side, top, back, the other side, and the bottom view, and isotropic view also. This is the isotropic view. Select any component, get into that, get to the normal. If you have a certain view where you want a screen, select save. Even though if you change and just click on this, so it will redirect you to that view again, as you can see it from here. So now you can switch it. Then isolate options, select isolate view. You can save it any way. Mask, unmask all. Then show and hide icons. So if you select that, the selected will be hide. So this is hide. Unmask all. On the view, you can close it. So I will pan it at bottom. Mask all, show all. Then the rotations, you can use 1D rotations or 1D translations, 1D movement, 2D planar movement using these planes, 3D movements, angle rotations. If you press shift at the origin of this, you can move this, and with reference to this you can rotate the model, make it a zoom pan, translate or rotate the model. You can control Z, mask all. So these are the translate and rotate icons. Measure icon, you can select the distance between 2 points. So this is the distance between 2 points. So you can select as many distances. Also, if you want to find the angle, just click here, the first, second and the third. So angle between these three. The angle between these three. So you can find the angle between the points. If you generally want to find the angle, just click here. And the angle between this. So in this way you can find the angle. Then the measure weight icon, select the load case, the gravity direction. If you want to see the CG, turn this on. If you don't want to CG, turn this off, and just click on calculate. If you click on bounding box, so this is the bounding box, as you can see, and you can see the package space extends, how much in X, Y, Z, and in volume, what's the volume of package space. Then weight of each of the support, mass of the component, center of gravity coordinates, warnings will be what are the loads and supports applied. So you can turn on that. So these are the some options which comes under the basic in Inspire. In the next video I am going to show you about the lines, right triangles, circles, arc, trim break, push pull, boolean options, and materials also. We will check the materials, like this is the material tab. In this I will there is a predefined material library, but if you have any different material than that, you can create a material here. So first I will delete the earlier materials and create a new one, composites. So I will rename it as and I can use this material. So if I want to use this material, right click, material, composite. So now the material is composite. If again I want to change, I can change it from here. I don't know why. So this is the material icon, helps to see the in which part what material is assigned, and also the material library, and create a material. So this icon is used for the materials. So in this way I have ended this session. I have covered in this session the file tabs, the view icons, configure icon, show and hide icon, translate, rotate icon, major icon, material icon, the unit system, the view options, rotating options, property editors, model browser and pull down menus. 5, where I am going to discuss about the modeling operations of SolidThinking Inspire 9.5 with the modeling session. In this session I am going to discuss about sketching, in which I will show you the options of lines, rectangles, circles, arc, sketching constraints, trimming and breaking. Then push-pull faces, boolean options, snapping tools, part instances and collision detect. So let's start our session with opening the GUI of SolidThinking Inspire. To open the SolidThinking Inspire, go to Start, All Programs, Hyperworks Student Edition, SolidThinking 9.5 Inspire. Once you click there, it will start ST Inspire 9.5. So this is the GUI. Today in this session I am going to show you about the lines, rectangles, circles, arc, trim, break, push, pull, boolean. These options we will see how to use these options, what are the different icons available here. So let's start with, so SolidThinking Inspire has a number of simple modeling tools for creating and modifying geometry. Sketch tools enable you to create lines and arcs on the faces of the part or on the sketch planes. You can also cut 2 or more sketch curves at a point of intersection using trim and break tools. So I'll show you the basic options here. Like you can create a box, you can push pull it, then you can create one more box in this, extrude it, you can have the circle, you can create a hole, you can remove it, so these are the options. You can do it in ST Inspire. So we will see one by one all the options available in ST Inspire. So sketching tools are used to build or modify parts by drawing sketch curves. A curve is a wire entities such as a line, rectangle, circle or arc. Closed loops of curve automatically generate faces that can be pulled into solids when you exit sketching mode. Sketching curves on an existing face breaks the face into subfaces. These can be extruded into solid material by pulling outward into the push-pull tool or turn into the hole by pushing inward. Open push-pull Open curves that cut across the edge of a face can also be pushed or pulled either to create new geometries or to carve away existing material. So we will see some of the options like lines, rectangles, circles and arc. So now we will see some of these sketching options. Like once you click it, you can see 4 or 5 options here. So I'll explain you what are these icons for. So the first icon is sketch on a new part. So this allows you to create a new part before you start sketching. Any existing sketch curve will be imprinted onto the current part before the new one is created. Now the second one is move current sketch to a new part. This allows you to retroactively move your current sketch to a new part. Then the third option, that is duplicate reference geometry. This allows you to create sketch curves from the reference geometry. Now the fourth option is create sketch planes. This allows you to create a new sketch plane by selecting new faces. And the last but not the least is the sketching options, will allow you to modify your grid and snap setting. So while sketching, you can apply geometric relationships such as tangency and perpendicularity to lines, arc and circles using sketch constraints. As you sketch, Inspire automatically apply many sketch constraints for you. This behavior can be disabled by using preference window, which can also be used to modify the default angle measures for certain constraints. So when you are finished sketching, right click to exit the active sketch tools. At the point you will still in sketch mode and may either select another sketch tool, click on sketch curve to edit it, on right click a second time to exit sketch mode entirely. When you exit sketch mode, the push pull tool is automatically activated so that you can immediately push or pull your sketch into a solid. So this is the sketch plane. The first thing is the sketch plane. So I'll show you the sketch plane. So I'll click on create new, so it will create a new part. We will create a circle with the center, right click it. So again, without exiting, we will create one more circle, right click and right click. So one part I can push forward, the other part I can push back. So you can see this. This is a different part, this is a different part. So in this way you can edit it. So this is the sketch plane which is on the face. Now we will move to the next. In the next, I'll show you to create a new sketch. To create a new sketch, you can select any of the one option. It will have the sketch plane. You can change the direction. It's, as you can see, this is X, Y. So if I want to change, just click on this. So select any one, you can just right click and you can change the, just click on this direction. This will help you to change the axis of the plane. So if you want to create any any sketch on any particular plane, you can change the axis at the global. You can see I'm just clicking on it and it's changing the axis. So you can change the plane on which you want to create it. So in this way you can keep on changing and create a new. So earlier I have created in the YZ plane, so you can create it in the other plane. So in this way you can create in the other plane, in which whatever plane you want. So now I will show you the first option, that is line. So in this we'll start with points. So with this option you can create the points on the grid. Once you finalize the points, you can just left click, it will get created. So just then right click, it will get finalized. Now if you want to move some point, you can move it on the grid, as you can see here. If I want to move this point, so I can move it in the grid wherever I want. I can move it like this. Just left click and drag the point, so it will get moved. So in this way you can move these points, and again once you right click, it will get finalized. So this is again the right click, now it's finalized. So these are the final points. Then the line between 2 points. So from one point to another, this is the line. One point to another. If you want some particular distance like 150 mm I want, you can also have. 20 mm you want, you have. Right click, you can also change the distance from here, the direction from here. You can just move this point. You can also move this point also. So before, just right click once to edit these points. If you right click twice, you cannot move this. So the parallel line can be moved parallelly. You cannot move it diagonally, it's a constraints. So in this way you can move it. So once you again right click, it will get finalized, as you can see. So this is the final line. Now the polyline, which is the continuous line. So you can have a continuous closed loop with this. You can also change the distance of any one line, like say if I want to 75, so this will be a bit smaller. If I right click, I can again change the dimension. One more shape I will show you. So I can change the shape as I want. So if it's not parallel, you can change the shape as you want. You can also make it parallel. Once it's become the parallel, it will. So if you have drawn it parallelly, so it will move it according to that. You can see you cannot move it like anything here, but here you can move it like as you want. So each and every point is free to move in angles also. So if you draw parallel lines, it will move parallelly. If you draw angular lines, it will move angular way. Now let's move to the another tool, which is the rectangles. So in rectangles we have three options. First is rectangles by corner, then rectangles by the 3 points, and rectangles by center and corner. So we will go one by one. Rectangles with corner. So you can create a rectangles with the 2 corners. Let's say if I want 100 by 100, so 100. Here also 100, and I don't find it good, so I will keep on changing it. So now I can change this. You can see I can change it as if I want. These are the parallel lines. You can also move the lines up and down. Say 100, 100. So this becomes 100 by 100 again. So just click on the line. You can have it as you want it. Again, right click to exit. So this will become a face. Now, rectangles using 3 points. So point 1, point 2 and point 3. So again, if you want this to be 50 by 50, this 50, 50 by 50. If you want to move it, you can move it with the same way as in the first option. So this becomes 30 by 30. So you can change it by changing the node. So you can also have it upside down, whatever edge you select. Then the next one is rectangle with center and corner. So center, if you drag it till the corner, you can also change it here by changing the dimensions. Right click will help you to change the dimensions also the same way. So these are the options available in right triangles. So now let's move to the third option, which is the circles. So in circles we have 3 options. First is circle by 2 point, circle by 3 point and circle by center and a point. So we'll start with the circle by 2 points. So point number 1, point number 2, you can rotate it here. This is the dia. If you wanted 50 dia, you can move it. So right click. You can also change the dia. Once the circle is done, then you can also move the circle also. So again, if you want 25, so it becomes 25, and if you want to move it or increase the dia, you can increase this afterward also. Then circle with 3 points. So point number 1, point number 2, and you can have a point number 3. Again with the dia, let's say 20, you can move the same way. The third point, you can change the dia or you can change the circle. So in this way you can change it. Then circle with center. This is the center. It will go, whatever you change, it will go around the center. You can have 75 as the dia, whatever dia you want, and also you can change the dimension. You can also change the center, reduce the dimension. So these are the options which you can do, and you can use these options. So in this way you can have like circular surfaces. So now let's move to the next tool, which is the arc tool. In arc tool we have 3 options, like arc by 3 points, arc by center and ends, and arc by the tangent to end. So we'll start with arc by 3 points. So the first point, second point, and the third point. This will create an arc. You can change the radius, say 20. You can change the degree also. let's say 180. So it will change the degree. If you want to change the length of this arc, you can do that also. You can move that particular arc to wherever you want. So in this way you can reduce or increase the arc. Now arc by the center. So let's say this is the center, length, and draw it. You can fix the degree, you can fix the size. If you want smaller or bigger, you can do that. If you want to move it, you can move it like this also. Or you can change the angles manually too. So we'll make it 270 positive. So this is the negative angle and this becomes the positive angle. You can change the length of the arc also to 10 to 25. You can keep on changing the length of the arc. Then the next is arc with the tangent. For that I want a tangent. So let's have this as the tangent. And then arc with the tangent. So this end starts and goes till this. If I want to move, I can move this, or else I can move like this also. This is the end point. So you can do as many edits as you want. So also you can change the length. You can move the direction. You can also change the angle. Let's say I want minus 125 degree. So the arc will go to opposite end. And if I want to increase it, I can increase it. So these are the edits you can do. So this is the third option in which you can edit the arc and the other options. So now let's talk about some sketch constraints. I'll have the new file. So we'll see about the sketch constraints. When sketching, you can apply geometric relationships such as tangency, perpendicularity, etc. to lines, rectangles, circles and arc using the sketch constraints. As you sketch, Inspire automatically applies many constraints for you. For instance, if you draw a line that is nearly horizontal, a horizontal constraint will be created on that line automatically, making it precisely horizontal for you. When you modify a sketch, the constraint ensure that the intended relationship between the sketch entities remain intact. We will see that. Rectangle having 2 points. So these are the parallel constraints. You can see perpendicular constraints, parallel constraints, the parallel constraints. Then if I want to have a line, and a arc. So this is the tangential constraints having the same tangents. Then if I want to have a circle, centroidal constraints, so it will be in the center automatically. Also, let's create one more like this. So now if you select these two and activate the parallel constraints, so this will be parallel, as you can see. Similarly, these two, if you want it parallel, so this will become also the parallel. It automatically shifts. You can see that. So these are the parallels. It will move in the parallel. It's fixed to the parallel. So wherever you change, it will change parallelly. Here also. So this will also you can make parallel. So it will not change the dimension. It will always move to parallel. So it's fixed to this, fixed to this. So you can apply these types of constraints. Also, if I create a line like this, let's say have a geometry something like this, and you can see that I can move these two lines. But what if I make it fixed? So this line is fixed now. So whatever I move, I can only move this line along this side. This is fixed. So you can also apply the fixed constraints. So as you can see, its arrow has come as fixed. So if you untick it, again you can move this line to any direction. Now it's not fixed. So you can fix or unfix it. Parallel, horizontal, these are also the constraints. Now let's have a line from this end to this end, and make this and this and this on a tangent constraint. So this will become a tangent to this. So in this way you can apply the sketch constraints on ST Inspire. We will have one more circle here, one more here. So this and this concentric. So this will become concentric. So you have to just, again I will show you how you can do it. Create a circle, create one more circle, let's say smaller. Just right click anywhere, control, left click, select both the circles, right click on any one, just click on concentric, so they will become the concentric. Now you can move both the circles. So if I want to increase or decrease any one, you can increase or decrease any one. So these are the sketch constraints which you can apply. So parallel, vertical, horizontal, and some more, the perpendicular constraints also. So I will show you that. So let's create one line, another line, right click, control, left click, select both the lines, parallel constraints. So these will become parallel. Perpendicular constraints. So this will become perpendicular. So you can move it. You can move this line. Like this, control, perpendicular. So now they will become the perpendicular lines. Control both the lines, control left click, parallel. So they will become parallel. So you can now move one line to the, but these are, if you click on one, make your mouse in one, so you can see the parallel constraint symbol is there. The double line, parallel constraints symbol is there. So in this way you can create a parallel constraints. You can also make this line horizontal to vertical. So both the lines will go to vertical or horizontal. So in this way you can edit these changes. Now let's move to the next, that is trim and breaks. I'll click new. So let's create a box with a center. First, let's have this box. Then to split line, like from here to here, then here to here. I'll make it arbitrary. Now I'll show you the trim option. With the trim, you can just left click to remove this. You can just remove the intersection points, you can remove. Again, right click, and once it's right click, you can edit it as you want. So if you want this like this, you can edit it. So in this way, or change the rules. So once you change the rule like this, you can change the shape also. So change the rule, and then you can change the settings. So this will help you to update the settings. So in this way, trim can be used. Now I will show you break. How to break option will you can use break option. So let's have a circle. It's easy to show here. So I will have a circle. Again, we'll have the split lines. 1 split line, 2, and let's use a break option. Here you will find a break option. Select the edge you want to break. I will break this. Right click. So this has been breaked. So you can remove it. So once you remove, this is a different part. It will be a separate part from the actual geometry. So what it is, break means, break will divide one component into two, but trim will remove that component or remove that line or remove that intersection. So if you use trim, so you can remove these sections like this. But when you use break, you cannot once you use break, you can move that part. So if I use break, this, and right click, I'll break it. So break into a different component. So you can use break to break the components into break the lines into some different segments, and trim to remove it. So these are the trimming and breaking options available in Inspire. Now let's move to the next option, that is push pull. So I will click new. Don't save this. I don't want to save it. If you want to save it, save it. It's good to have the save files. So the push pull faces tools is used to push or pull flat or cylindrical faces created with the sketching tools. It can be used to extrude solid from faces, create a resize holes, modify or eliminate rounds, and modify wall thickness. This tool is useful for defeaturing a part to make it suitable as a design space for optimization. Pushing and pulling without snap. As you push or pull face, a ruler appears showing how far the face has been pushed or pulled. If you have snap enabled in the preference window, so edit preference. Here we will see the snap enability, snap to grid. If it's enabled, you can see this. If it's not enabled, you cannot see it. So you have to make sure that it has to be ticked, otherwise you will not see. Then as you push or pull a face, it will automatically snap to snap point as you pass over them with the mouse. Pulling face with rounds. When you pull a face that has round adjacent to it, the rounds are moved with the face. Sometimes complex rounds and blends will prevent a face from moving because they can't be constrained at the desired position in the face is moved. If you don't care about retaining the rounds, you can often free up a struck face by pulling out the rounds with the push-pull face tools until it becomes a sharp corner. So let's start with first to extrude a solid from a sketch. So let's create a sketch first. So this is my sketch. Right click to make it final. Right click to make it a surface. Just center mouse button, rotate it and pull it. I can create one more. Right click in this face from this center. One more hole. Right click, finalize. Right click, surface, and pull it again. So this is the bar. If I want 25, so it's a 25. If I want to make it a separate part, I can make it a separate part. I can also push pull this without any issue. So I can push pull the faces. So you can push and pull the faces to change the shape of the object. Now finalize. Again right click, just move it a little. Now we will see how to create a hole in a part. So if I want to create a hole, circle with any one option, create a circle. Right click, finalize. Right click to get into the surface and drag it backward, or just rotate it a bit, drag it back. This way you can put a hole on the model. Right click to finalize. To change the diameter, now we will see how to change the diameter of the hole. So to change the diameter, push pull face, just click on push pull face, select the cylindrical part of the hole, click there, and you can change the diameter. You want big, you can make the specific one. So in this way you can change the diameter of the circle anytime you want. Now we will see to change the radius of simple cylindricals. So if you want to change the curvature, then also you can do it. So what I will do is I will create one for you. Okay, just right click. So what I will do is create some lines from here to here, similarly from here to here. Right click from this to this, and move it something like this. So I got a new part, as you can see here, the curved part. Push pull face will allow me to change the dimension of this too. If I want to change it, I can remove it also. So you can change the dimensions of curved parts, the radius. If I take out this, it will be fixed. So you can change it like this. So it's becoming flatter. As you can see, this becoming flat instead of curved. Shift and right mouse button, you can flat it down. So this is becoming flatter and flatter. Or again, push pull the face. So in this way you can use the push pull command to change the shape of the component. These are very helpful to edit the geometry very quickly. They don't require much of the experience or efforts to edit the geometry. So in this way, we have ended with the push-pull command. Now let's move to the next. So now we will see the Boolean options. So I will click on new, don't save. So to show these options, I will create one rectangle. Let's say, okay, or a bigger rectangle. Let's say a bigger one. Or 50 by 100. So we'll have a 50 by 100. Right click, finalize, turn the model, extrude it a little. Yeah, it's fine, good. Again, right click, so it's finalized. My box is finalized. So what I'll do is I will have some circular joints here. Let's have two circular points. So this will have one, this one, with a new part. So create a new, create new. So what I will do is I will have a part here. Then again create new, circle here. So I have 3-4 parts. So I will rotate, finalize, and extrude it to this. This will I will extrude it to this end. So now if I click on this, 1, 2, 3. So I have 3 different parts. So what I'll do is first let's check with the addition or combine. So select part 1, part 2, part 3 and just click on combine the arrow, play arrow. This becomes the one part. It's very simple. Again we have 3 different parts, part 1, part 2, part 3. Now if you want to subtract the extracted part, so click on subtract, keep the which part you want to keep. So I will keep this, and which part you want to remove, so I will remove this and this, and just click play. So you can see the pipes which we have extruded, it has removed those pipe areas. Then we will see the last option, that is intersecting parts, the reverse of subtract. So I will select this option and this one and this one, and just click paste. So you can see it will keep only this. If you want in keep, make this keep. So this will keep, or what you can do is keep this one. So first select this, then select this and this. Remove it. So Boolean options, this option, and select the other, which one you have to keep, and say play. So this is the intersecting one part, this is the intersecting 2 different parts. So in this way you can use the Boolean option to subtract, add and intersect the parts. So these are the ways to handle it. You can undo that also. Okay, so now the last point of today's session is collision detect. For that I will have a model for me. Let's create a box. has fails with new part. This. So why I created it? As you can see, these are the two different parts. Part one, part two. Okay. So what I'll do is I will turn on the collision detect of both the parts. So what it will do if I move this part, it will not go inside it, as you can see this. So it's colliding. If it's colliding, it will not intersect between. But if I turn off it, for both the parts, if I turn off, so it can pass through it, as you can see. So collision detect is very important. Depending on your model type or your component, whether you want the part to intersect between each other or if you don't want the parts to intersect between each other. So you have to decide whether you want the parts to collide or you don't want the parts to collide. So today we have discussed about how to create lines, rectangles, circles, arcs, how to use trim and break, push, pull, boolean. Now in the next session I will show you the shape controls, load, displacement, optimization and material also. In today's session I am going to discuss about the optimization operations available in ST Inspire and how to use them. Then files. So in today's session I am going to discuss about design space, pattern repetition, loads and displacement, shape controls, running optimization. So these are the things which I am going to discuss. So let's start about the basic theory of optimization, where it states that optimization is the process of generating a shape in response to load cases and is the core of SolidThinking Inspire. The optimization process carves material away from the design space, creating the lightest structure capable of withstanding the force you apply to your model. Note that optimization only works on parts that are defined by solid geometry. Parts which are mesh, such as imported STL files or FEM files, are ignored. In order to perform an optimization, you must first define a design space and one or more load cases containing both loads and supports. You can also apply various shape controls such as symmetric planes, cyclic repetitions, and draw direction as well. You then run an optimization and await the results, which can take a few minutes to few hours depending on the complexity of the model. Once the results are complete, you can interactively explore variations of the resulting shapes. Not all parts in the model need to be design space to run an optimization. In many cases, you will need to apply loads and displacement to the parts surrounding the design space in order to properly define your model. However, only the design space itself will be optimized. Note that any part that are in contact with each other are considered to be welded together with no slippage. This section explains how to define load cases, apply shape controls and run optimization. So let's start with the design space. Design space is the initial part from which material is removed until a final shape is reached during the optimization. You can create a design space by using the modeling tool in Inspire or by importing parts from other solid modelers. Any part that is a design space will be reshaped during optimization, while any part that is not a design space will remain as it is. You can have any number of design space in your model. Parts designated as design space are displayed with a reddish brown color as shown below. So a design space can have any shape or topology as long as it is a single solid volume. A part that is used as a design space should not be very detailed. To ensure the most freedom to generate a shape, you should not use the simplest design space possible. The more fine details you have in the design space, the longer it will take to run the optimization. A shape generated by optimization is contained entirely within the volume of the original design space. Since material is only removed, not added, you specify the amount of material to keep either as percentage of design space or by entering a target weight. So below figure you can see the entire volume with the change in the design space. So this is the optimized shape of the bridge. So now I will show you how to divide a part into design and non-design space. So let's open the ST Inspire 9.5 GUI. To open it, go to Start, All Programs, Altair HyperWorks, Student Edition, SolidThinking Inspire 9.5. So this will help you to open the GUI of ST Inspire. Let's open a model, any model. Just I want to show you how to divide a component into design space and non-design space. So as you can see, this is already divided into design and non-design. So if you right click, deselect it, so this is a normal part with every component in a non-design space. So you just select the part, right click on it and check the box here, design space. So this will become a design space. Similarly, you can make this also a design space. So whatever component you want, you can make it in the design space in this way. Similarly, you can make it a non-design space. Also, once you select a part in the model browser, you can change it into design space from the property editor. Also, here you will find a design space option. As you can see here, if you untick it, it will become a non-design space, but when you click check the box, it will become a design space. So the reddish brown color means it's a design space. So during the optimization, the software will remove the material from the design space. So you have to make sure that you put a actual component which you want to optimize in the design space, rest all in the non-design space. Now let's see about the pattern repetition. When an instant part is designated as design space, Inspire will automatically apply pattern repetition to design space so that they generate identical shapes during topology optimization. This is useful when designing a part which exists at multiple locations in an assembly, with each instant experiencing different loads depending on its position in the assembly. So now I'll show you how to create an instant parts. So let's make this non-design and this one with a design. So what you have to do is just select the parts, right click it, copy, again right click, and instead of paste, click paste instances. So paste instances will help us to do the pattern repetition. So if you click on paste instances and move the part, so select these parts and move it aside. Now turn on the rest of the component. So whatever material it will remove from this, the same amount of material it will remove from this, and the same pattern, the pattern will be same. So this will help us to do the pattern repetition. So you have to copy and paste the instances, that's for sure. So you have to paste the instances instead of creating a paste. If you paste it, the optimization will not follow the pattern repetition. So paste instances will help you to follow the, will help optimization or ST Inspire to follow the pattern repetition. Now we will see about the loads and displacement. So before running optimization, you need to define at least one load case, a set of load and displacement that acts on your model. Load includes forces, pressures and torque, while displacement includes supports and displacement constraint. These are created by clicking the selectable areas on the load and displacement icon group on the toolbar as shown in the table below. So this icon you will find in ST Inspire 9.5. So I will show you how to use it. So I'll explain you what are these. So first is to apply force, this arrow. Then to apply the pressure, you can use this. To apply torque, you have this icon. To apply supports, that is constraint, you have this icon. To apply displacement constraints, you have this icon. So all of the loads and displacement in the model are shown in the model browser in a folder called all loads and displacement. The loads and displacement included in each individual load case are displayed in subfolders as well. Any load or displacement can be included in multiple load cases and therefore may appear multiple times in the model browser. Alternatively, a load or displacement might not be included in any load case, in which case it only appears in all loads and displacement folder. This folder only appears once a load or displacement has been applied. So now I will show you how to create the loads and displacement constraint. So what I will do is I I will delete these copied things, just delete, and move it in the center. So F will help to fit to screen and show all. So you can see the forces and constraints are already applied on this. So what I will do is delete all the forces and constraints. So to apply force, you will have this icon to apply force, this single arrow. You can apply the force on edge, like in directions, in angle, just double click to get enter to the editing panel. So you can have it in any angle. So whatever angle you want, you can edit it here in this way. If you want it in 45 degree, just put 45 degree, minus 45 degree. Then you can select the direction. You can have a point load or distributed force, point force or distributed force. You can change the magnitude from here. If you find it in not in Newton, so you can change it from here, let's say lbf, so it will be in lbf. So if you want it Newton, you can have it in Newton. So in this way you can change it from here. You can change the direction, positive, negative, the direction of force. Similarly, you can apply the force on the surface. So change the direction, perpendicular to the surface, positive, negative. In the surface also, point, as this is a curved surface, you can have a center force applying to it in the direction you want. Point force at the surface, perpendicular to the surface, it will automatically be perpendicular. Change the magnitude. So you can apply the force on edge, on the surfaces. Also you can apply the force on the circular areas, the board location. So you don't need to create the rigids in if you want to apply the force here. So you don't need to create the rigids. You can similarly change the direction. You can have the perpendicular force. You can have the negative, positive. You can change the angle of force in what way you want. If you want some angular force, you can change it like this. It's very simple to change the force here. So you will have the angular force. So these are the ways you can have the edge force, surface force, and a center force with the rigids. It automatically creates the rigids. It automatically creates everything here. So you have to just apply the force, give the magnitude, rest ST Inspire will do. So it creates all loads and displacement folder where it puts forces and a load case. So you can create a load case. I will show you in the later session. Now I will show you how to apply the pressure. You can apply the pressure so apply the pressure on the entire surface in positive, negative direction. The magnitude of the pressure, it will keep it as pressure. You can have the pressure inside the surface like this. change the magnitude, finalize. So you can add the pressure in much simpler way. So this is the way to apply the pressure. Now you cannot add pressure on the edge. So either you have to select the pressure for the on the surface, whether inside or outside. Then the torque, just click on this, select the surface where you want to apply the torque. Here you want to apply the torque. So the direction of torque, positive or negative, clockwise or anti-clockwise. If you want some particular direction of the torque, or in particular angle you want the torque, you can use that. Then the directional axis of the torque, in which axis you want, and the magnitude, Newton per mm. You want to change it, you can change it from here. So in this way you can edit the torque. So these are the ways you can apply the forces. Multiple forces you can apply on the surface. So these are the ways you can apply the torque. Now we will see about the constraints. So this icon is used to create constraints. So you can apply the constraint on edge as like force, point constraint, multiple point constraints. Also the direction, if you want to change the direction of the constraints. Perpendicular to the edge, single and multiple. Then if it's all transparent, that means it's constrained to all the degrees of freedom. If you tick any one axis, that means it is free to rotate or it's free to translate in this particular axis. So translation is free. So this in this way you can apply the constraints. I'll again show you. Now you can apply the constraints on the surface. Just select and apply the constraints. So now there is no use of this constraint, it's free for all, so it's not applying. So you have to make it like this. So this is showing the global axis, Z, X, Y. So I am constrained to Y. Here I have constrained to Y and Z. So in this way you can put the constraints whatever axis. If you make it all green, so it's of no use, it will be like invisible. So you have to make sure that any one is active. So in this way you can find it that one axis is active, two axis it's constrained. So in this way you can apply the constraint to edge, to a surface. Also you can apply the constraint on the board locations. So this is the constraints on the board location. You can have a point constraint, surface constraints, inside all, and the center constraints with a rotation on. So, and this is constraint to torque, constraint in the direction. So it's free to rotate in that direction. Translate in this direction is fixed. It's free to translate in this direction, but the rotation is fixed. So in this way you can apply the constraint. So you have to just tick it. If I click here, it's fixed. So in this way you can apply the constraints. So I have fixed the rotation. Now the rotation is free and translation is fixed. So it will not translate in this direction. So if you want to apply the constraint, you can apply the constraint in this way. fix it. This is all free. So if I free it all, so you can see it's free to all. Okay. So once I right click, this component is free to rotate and translate. But if you want to turn off, you can turn off it. So now it is translation and rotation is locked. It is constrained to translate and rotate in this particular direction. Point. You can change it like this. So point, you want in some direction. Surface, you can have this direction. And here you can have the rotation. So in this way you can edit it. So these are the ways to edit the constraints. Just click to add the constraint. You will just need to click here to add the constraints. So in this way the constraints have been added. Now the displacement constraints. So this is a single displacement constraint. So this helps us to define that the part will not displace till this point. So this is the displacement constraint. I can make it an mm. You can reduce the size to 1. The direction, and you can change it to double displacement, so it will not displace in this. So it is allowed to displace further, but now if it's a double displacement, it will not go further. It will only displace in this region, not more than that or less than that. So this is fixed, this is fixed. If you turn off, it's off. If you turn on it again, it's on. So you can turn off this, so it's fixed. You can change the direction, make it perpendicular, and change constraint in one direction, constraints in all direction. So if it's a single, it's constraint to all direction. This ball means a constraint to all direction. It is not allowed to displace in any one of the direction, any direction. But if you want, you can make it to if you make it in the single direction, you can do it like this. So you can apply the displacement constraints like changing it. So single support is capable of reverting translation in XYZ direction. By default, translation in all three directions is locked when the support is first applied, but you can double click the support con to enter editing mode. Once in editing mode, transparency arrow appears, you can toggle translation or fix all. So in this way you can edit the constraints. So the displacement constraint can be applied to a model to limit deflection in desired location and direction. These constraints should only be applied to a non-designed space, and while they can be used as the sole constraints for an optimization, we recommend using them alongside a stress constraint. You can apply displacement constraint to a model using the apply displacement constraint tool in the displacement icon group. They are represented by pyramids that appears orange when selected and blue otherwise. So its otherwise is blue. So in this way you can apply the displacement constraint. A displacement constraint is applied at a particular point on a model. You can choose to limit displacement in one direction or in all direction, as you can see here. So we have defined in one direction or in all direction the displacement constraint. Now I will show you how to manage the load cases. So it has created one load case, as you can see here. while I am defining the loads and boundary condition, it is defining one load case. So I'll show you how to manage the load case or define more load case. So what I'll do is just right click here on the load case, create new load case. So you can have case as 1. If you want these things in one load case, you can just drag and drop. So this will come in the 1. So if it's off, this will become the off. Similarly, right click, new case 2. I want pressure, support, displacement and support 13 in this. So now this has one set of load case, this is second set of load case. So in this way you can edit the load case. It's very fast, quick. Now if I want to delete it like this, I don't want this, it's been problem, so just delete. Here also you can just delete. It's simple to delete. You can delete multiple load cases also. Delete. Just press delete button from your keyboard. So torque you can just delete, and you can have a copy paste. So copy in this, paste. So you will have a torque constraint here. So a torque constraint can be applied twice. So just copy and here click and paste. So you can have a torque here also. So we have a torque in 3 different load cases. So why I copy pasted it? So for this case, let's suppose I want a torque to be in some other direction. So let's off this. So you can have a copy paste, and if you want, so if you want the torque in some other direction, you can change the direction for that particular load case. So this is for this particular load case. So in this way you can edit it like this. So in load and displacement, there is one point which I want to discuss with you are why are my results disconnected? When you use displacement constraint, it is important to either apply them near all the major loads or to use both stress constraint and displacement constraint together, as shown in the first 2 images below. If you apply a single displacement constraint 2 mm at the tip of the foot peg, the results are biased to only account for that displacement constraint. The third image shows how the optimized result changes if the stress constraint with factor of safety 1.2 is added to displacement constraint. The resulting shape can resist the stress applied while maintaining a total displacement of 2 mm at the foot peg. So this will be a tip and tricks like for ST Inspire. Now let's move to shape controls. So shape controls are used to include symmetric shapes, shape with cyclic repetitions and shape with raw direction for casting and stamping. While optimization always requires the presence of loads and to generate the results, applying shape controls is optional and provides additional design goals that must be satisfied by the optimizer. The 3 basic categories of shape control tools that you can apply to a part are symmetric planes, cyclic repetition and raw direction. So I will show you now how to use it. Okay, so what I'll do is I'll create a new structure to show you the shape controls. So I'll click new, don't save. Let's have a new structure. It's quite easy to create a new structure from here to here like this. Done. Right click, rotate a model, zoom. So this is the box. Now first we'll start with symmetry. So we have symmetric, cyclic symmetric, cyclic rotation and cyclic symmetric. So this is the symmetric, so this is planar symmetry along xy plane, yz plane, zx plane. So if it's turn off, it will be not a symmetric. You can turn on to be symmetric. If you want to change the axis of symmetry, you can do that from here. If you want perpendicular to the axis, you can have this icon to make it perpendicular to the plane. From here you can change symmetric, cyclic symmetric, cycle repetition with symmetry. So we'll see cyclic repetition on this model. So 3 sections, you want 2 section cyclic repetition, 10 section cyclic repetition. So how many sections cyclic repetition you want, you can have it like this. Similarly, you can change the angle of cyclic repetition, whatever angle you want. Then again I will click here. You can have the direction in which axis you want the cyclic repetition. You can edit it from the corner, so you just change the number of cyclic repetitions to how many numbers you want, you can change it. So all the patterns will be same along all the components. Then cyclic symmetry. So it will repeat the same pattern from 1, 2, 3, 4, but it will have the symmetry, like whatever here, same as this. So it will have the repetition with the symmetry. So this option will help us cyclic repetition with symmetry, like as it is showing. So cyclic repetition with symmetry, and this will only have the cyclic repetition, means you can it will have the same division across, same amount of material removed as the repetition of the material remover, but the symmetry will be same along this. So like you can have less number of symmetries, whatever, the same options here, change the direction and change the magnitude also. Want perpendicular to the surface, you can have the perpendicularity to surface. Then I'll just remove it. Then the extrusion parameters, draw directions. So let's see the draw directions. We have 4 draw directions in SolidInspire. First is single draw direction, split draw direction, stamping and extrusion. So let's start with the single draw direction. In which axis you want the draw direction to be? This axis, this plane. You can move it. The plane you can also move. Holes, no holes. The direction of split, you can rotate the split axis if you want. You want to translate it, just translate it. So in this way you can translate or make it to perpendicular to the axis. The center of the component. Then you can change it to split draw. So this option will help us to create a split draw. With, if it's on, that means it will not create any holes. If it's turned off, it may create a hole. So no holes and holes during the splitting process. Direction, then same axis, center to the geometry, and they align to global. So this will help you to align to the part, align to the global. So if you change it, anything you change like this, and you don't want like, so you can align it to global. It will get aligned to global automatically. So it's very easy to change the settings in SolidInspire. Now we will see stamping. stamping with holes, no holes, the direction of stamping, the angles, align to part, align to global, the same options, and extrusion process. Extrusion process will never have that hole or no hole option, but will have the direction, in which direction you want the extrusion process. Align to part, if you want to change the global axis, you can change it from here. If you want to change it on along any one axis, you can change it to along the axis. So from here, if you want to start, from here if you want to start, you can change it like this. If you want it in some plane, you can move it to the plane also, or else just double click align to part. So it's aligned to part. So in this way you can edit the shape controls by extrusion. Just right click to go to the main menu. So some draw directions and symmetric results. So these are the options available to which you can use in ST Inspire to get a good results. This really helps to get a good results. I'll show you in the tutorials that how the shape controls help to get a better results after the optimization. Now let's move to the last topic of today's session, which is running optimization. Options available which we can use to perform a run in a ST Inspire for the optimization. So optimization generates a shape for each design space in a model in response to the load on that model. It carves material away from design space, creating the lightest shape possible to withstand the force that you apply to the model. You perform optimization by defining at least one design space and one or more load case that contains loads and support. If desired, you may also apply displacement constraint and shape control. Then you run an optimization and await the results, which can take few minutes to a few hours depending on the complexity of the model. Once the results are complete, you can interactively explore variation of the result shape. In general, it is best not to apply loads and displacement directly to design space, as this often leads to incorrect results. Instead, you should split the part into design and non-design space and apply loads and displacement to the non-design space. When you run an optimization, you specify the name of the run and optimization objective in the run optimization window. Depending on your objective, you may also want to define displacement constraints, mass targets, stress constraint, frequency constraint, thickness constraints, and whether or not gravity should be applied. Inspire perform check to ensure that the model is properly prepared and load cases are checked to verify the appropriate support to the load exist. If any problem is found, you are given help on how to correct them. Let's see what are the options available in. So now let's see what are the options available in run optimization. Let's open the same model. So this icon is used to enter to run optimization panel. Just click, it will have a tab here. You can move the tab anywhere you want. And this is the run history. Whatever run you do, you can check it from here. Once it's run, you can see the solution here. As you can see, this is my model. Don't save. Click new, don't save. So from here I can just open the model, the results model, you can see. So this is the result model. If I click here on this, so this is my optimized shape. I can change this topological shapes variation. So in this way you can do it. New. So this is the run history. The first icon in here is run history. Then run optimization status. This will help us to see the run optimization status. So whenever you click run, it will start automatically. So this is history. If you want, you can delete it all or check the run optimization status. Now I'll show you the run optimization tab, what are there. So we'll start with the name. First is the run name. So I will first start with the run name. You can put any one run name, whatever you want. So run name, specify when you run an optimization, the name of the run defaults to the name of the part used as the part design space. However, you can assign your own name to the run optimization window. When a run is made, the name is appended with several parameters to identify it, including the optimization objective, mass target or safety factor, stress constraint, frequency constraint, and whether a displacement constraint has been applied, as well as counter that is incremented each time you run an optimization on the particular part. So these are the details. It comes along with the run, name of the run. So I will put it as run 1. You can change any one. Then objective of the optimization. So there are different objectives of the optimization. So when running an optimization, you must decide whether your objective is to maximize the stiffness or minimize mass. So there are two objectives: maximize stiffness, minimize mass. If you maximize the stiffness of the design space, the resulting shape will restrict deflection but may be heavier as a consequence. If you minimize mass, the resulting shape will be lighter but may deflect more. Give a particular design space and a set of load, displacement, shape controls applied to your model. You will see different results depending on which objective you select in the run optimization. So depending on your objective, you will get a different results. So if you select maximize stiffness, so maximizing the stiffness of a design space will result in shape that is the stiffest possible for a given mass. If you select maximize stiffness as your optimization object, you will need to specify one or more of the following. First is mass target, second is frequency constraint, and the displacement constraint. So these you have to specify. If you select maximize stiffness, then if you select minimize mass, so minimizing the mass of a design space will result in shape that is lightest weight possible, which can still support the applied load. If you select minimize mass, your optimization objective, you will need to specify one of the following: stress constraint, frequency constraint, and displacement constraint. So the minimize mass optimization objective is normally used with stress constraints. One, optimization is complete. The best results with minimize mass is generated, found by dragging the topology slider for far right to the shape explorer window. The optimization results is the point at which all the loads and support locations are connected. So this will help us to define these constraints. Now I'll show you the other options, that is the mass target. So when your optimization objective is to maximize stiffness, mass targets are used to specify the amount of material to keep. This target can be defined either as percentage, if you click here, so either as the percentage of the total volume of the design space or as total mass of the entire model. If you have more than one design space, you can set target of each design space individually. You can also set the mass target to none. So if there is no mass target, you can select it none. So percentage of total displacement, if you select, this means one portion for specifying a mass target is as percentage of total volume of design space. For example, if you specify 30% mass target, then 70% of the material is carved away from the design space, leaving 30% of original material. You can specify more than one mass target percentage at a time, with each target producing a separate run. Note that optimization may not always produce an answer for every percentage you specify. As the lower the percentage, the more challenging it is to produce the answer. Typically, percentage range from 20 to 50%. Then if you select total mass, So a second option for specifying a mass target is to enter the mass of the entire model. This is the total mass after optimization. So including both design and non-design space, you can specify more than one mass target at a time by entering values separated by comma, with each target producing a separate run. Keep in mind that lower the mass target, the more challenging is for the solver to produce the answer. Then if you select specify per design space, so if you have more than one design space in your model, you can specify the mass target at each design space individually. Choosing this option opens a table listing of all the design space where you can enter a target mass of each. In the table, you can specify a mass target directly, or you may enter a target as percentage for design space mass. So you can put a percentage like 40%. So target mass is like current mass to target mass, you can have like 10%. So you can change it, or you can put it like from target mass to here, the actual mass to target mass. If you want it in kg, so this is the kg. It's 0.74 kg, so 10% of 0.74 is 0.74, 50% is this. So it will keep this, rest it will remove. So these are the options in mass targets available in ST Inspire. Then the stress constraints. So if you select minimize mass, you will have the stress constraint. Global stress constraint can be applied to limit the maximum stress in the model, and is used when your optimization objective is to minimize mass. Inspire analyze the material used in the model to determine which has the lowest yield stress, then divide it by its minimum safety factor. The higher the safety factor, the more material will be added to the optimized shape. To limit the overall stress in the model, stress constraints are automatically enabled when minimizing mass. The motorcycle bracket picture, as you can see, will help you to understand that. So if you can put none, you can have the minimum safety factor like 1.2. I want minimum safety factor or factor of safety to be 1.2, not less than that. So you can put it like that. So this is the option available for stress constraint. Now the rest of the other options are same for both, they doesn't change. So whatever option you select, the frequency constraint, thickness constraint is same. So I will now explain you what is frequency constraint. In some cases, you may want to change the natural frequency of an object so as to avoid resonance with other parts in your design. If you want to control the frequency at which an optimized part vibrate, you can set frequency constraint before running an optimization using the run optimize window. So you can have the frequency like maximum frequencies, use supported load case, so for which load case you want, or minimum frequency, this will be the minimum applied to the lowest 10 modes. This will be the minimum, it should not go beyond this. So when maximizing stiffness, you may choose to either maximize frequency or set a specific minimum frequency. If you choose maximize frequency, Inspire will automatically maximize both the stiffness and frequency of the model, and the lowest natural frequency will be displayed in the Shape Explorer window. If the resulting frequency is not high enough to meet your constraint, you may need to assign a stiffer material or modify your mass target for the optimized shape. When minimizing mass, you may enter a specific minimum frequency and specify how many of the lowest mode must exceed that frequency. If Inspire is unable to achieve the specified frequency of the lowest mode, this will be flagged in the Shape Explorer window, or in the certain cases the optimization run may fail. If this happens, try assigning a stiffer material. So changing this will help you to get a stiffer material with a frequency range. You can also control the frequencies of your model. Then the thickness constraints. So when running an optimization, you can control wall thickness and diameters of beam-like members and shape by specifying a minimum or maximum thickness in the run optimization window. Wall thickness and beam members, so minimum and maximum. So Inspire provides wall thickness and beam member thickness are controlled by the same parameters. Inspire provides default values for both thickness constraint. The maximum thickness constraint is only enabled if minimum thickness constraint is enabled first. So first you have to enable minimum thickness, then only the maximum thickness is enabled. The default minimum thickness is 3 times the average element size. The default maximum thickness is 2 times the value entered for minimum thickness. So whatever you specify here, if it's the minimum thickness is not active, you cannot have the maximum thickness directly. So the minimum thickness is 3 times the average element size, and the maximum thickness should be 2 times the value entered in the minimum thickness. So if I turn on maximum, and if I want it 0.0001, so it will give a warning. You can see the maximum thickness should be set to at least 2 times the minimum thickness. So change it to the 2 times, it will automatically change. So now let's go to the gravity. So now gravity, if the weight of the structure is a significant portion of load it is bearing, then you should include gravity when running an optimization. Larger objects like building and bridge must support their own weight and should have a gravity applied to them, while small stiff structures that don't flex under their own weight should not have a gravity applied. When applying gravity, you must always apply some force, pressure and torque to your model as well. If there is no force or other forces are very small relative to the weight of the structure, optimize will result an empty structure. Gravity pull towards negative z axis by default, but you can change the direction of the gravity. I will show you how to change the gravity. So if you want to change the gravity, like for this model, this is the direction of my model. Let's say my model is in this axis. In this way I am going to put it like this. So my gravity will work in positive x-axis, so you can change it from here, positive x. So it will, now the gravity act will downward. So you have to see the gravity of your model, and accordingly you have to apply the gravity. And you can select here the load cases. From here you can select the load cases for which you want to run. So if you select all the load cases on your model browser, so the optimized result will have the shape supports for all the load cases. But if you have a specific run, so then the optimized shape will have the optimized shape will only specify the results of the one particular load case. So it depends on individual and the components how you want to use the load cases. So you want to turn off, turn on, reverse. So you have multiple load cases, just reverse. You can export the file to FEM. This will help you to solve in the HyperMesh. So this will help you to prepare and export to OptiStruct. So this way you can create an FEM file of this model and export it to FEM, and then open it in HyperMesh. You can import it in HyperMesh after its export. So in this way I have covered the optimization options available in ST Inspire. They are as shape controls, loads, displacement and optimization. Material also comes in this, but material I have already discussed. So with this I have covered all the tools available on the GUI of ST Inspire, how to use them, what are the different options available in that. So I have covered all these things. So lastly I will show you I have exported that file into FEM. So let's open HyperMesh and import that file. So I'll select that file, import to optimization, close, hide the load cases, hiding the system. So this is the model with a design space with all the different components and with a proper meshing done already. So with the rigids and all, so it already have everything. So the material you assign, it will have that material also. So whatever thing you have, it will automatically upload updates. So in optimization, say topology, go to update and select it. So it will have the parameters. It doesn't have any draw direction, so it will not have. Then in the responses, if you see, it has the responses, volume fraction, mass fraction, frequencies. Then in constraints, you can see that these are the constraints, and the objective will be, you can see. So everything it has, it creates by default materials, and then the properties, design variable. So ST-Inspire creates the complete set of topology optimization, or you can do in Hypermesh also, but it's very easy to use it. So that's why I just show you how you can use the ST-Inspire to get a optimized shape quite fastly. So you can see here it's quite easy to handle here and change the design components. So if I want to change the thickness here, I can simply change it to thickness. Done, man. The thickness has changed, you can see. If I want this whole till this, yeah. So yeah, this is through. So in this way you can edit the model quite easily, and in this the meshing is automatically done. So if you select here the design space, if I scroll up and turn off this, I want an mm. Let's say I want an mm. So my minimum element size, let's say 0.1, and the maximum will be 1. So again I can go to file, run optimization, export the file again. Let's see what difference it has. Okay, so this is the old, again the new. Go to import, select the file. This is one. Import. So it will take a little time to open it, because I think the element size is drastically increased. So I have given a very less element size, that's why. So hide the load collectors, hide the systems, press F from the keyboard, mesh. You can see it has done the meshing with the dense element size only for the design space, because I have given the parameters for the design space only. So if I turn on this and this, so they have the overlapping. So these are the rigid faces. If I press F, this different rigid spaces. You can see, and on this it is. So in this way, just change the meshing or change the boundary condition will help you to get the results here. So in this session, that is the first tutorial in which we'll see the how to getting started with this ST-Inspire. Here we will see the user interface, importing files, view controls, showing and hiding parts, creating and editing forces and draw direction, how you can do these things. So let's start with the SolidThinking Inspire 9.5 GUI. To open it, go to Start All Programs, Hyperworks Student Edition, SolidThinking 9.5 Inspire. Once you click Inspire, you will it will open the GUI of ST Inspire 9.5. So we will start with the first. I have already discussed the GUI icons, the icons and the model browser, property editor, all the other things I have already discussed. So let's open the model as dual bracket. So this is my model of dual bracket. To open a model or import a model, select open model, and you can select the file, which type of file you want. You can also select that. So you can import that files from any CAD software. Now to rotate a part along the three global axis, right click and rotate. To rotate a part anywhere in the space, you can use the center mouse button. To pan the model, press shift and right mouse button to pan it. To zoom in, zoom out, scroll up, scroll down. So just left click to select, right click will get into the different options, and left click anywhere in the GUI to deselect the option, to deselect the part. To hide the component, just click on this icon and click to hide them. So this guy hide, so you can have the reverse all, mask all, unmask all. So this will be hide all, show all, reverse, hide and show. You can just select the component, press H from the keyboard to hide them. That is a other way to hide the component. Or if you press A from your keyboard, so hide all and show all option will be there. So these are the some hide and show options. You can hide and show from here also, mask, unmask, select. So this will get hide, reverse. This is the highlighted one. Show all, hide all. So these are also the show and hide options. And select any model, press I from the keyboard to isolate that model. So only that model will be visible on your screen. Now let's apply some forces on it. So apply the forces, let 45 Newton, change the system to SI unit. So 45 Newton, you can change the direction. Apply the draw direction. So in this way you can apply the draw direction, change the. Now I will show you how to edit it. So just double click here on the draw direction. You can edit the draw direction parameters. So I want the draw direction with no hole in this. So this is done. Similarly, you can edit the forces, apply the forces wherever you want. Change the direction of these forces. You want it to a point, so you can make it a point force or UDL. So this is the point force and a UDL. So point force, UDL, you can shift it to like this, negative, positive. So in this way you can edit the forces. So in today's session, that is tutorial second, moving and snapping, we are going to see opening and importing models, moving parts, snapping to points, copying and pasting, translating and rotating, and organizing a model. So we'll see a model and how you can do these different options or these different processes in that. So this is the GUI of SolidThinking Inspire 9.5. To open it, go to Start All Programs, Hyperworks Student Edition, SolidThinking Inspire 9.5. and click on Inspire. So with this you can open the GUI of SolidThinking Inspire 9.5. To open a model, click on Open folder. We will select bracket dot tx underscore t file and click open. So this is my bracket model, as you can see. Before going further, we will just quickly check about the view, edit preferences. In that we will see compatibility and check whether the HyperOS compatibility is off or not. So it has to be off. If it's on, turn it as off by just clicking it on off. So it's easy to copy paste with this option I'll show. Say apply and OK. And also we will import some more files, so like paste, bolt and pin. So these three files we will just copy and paste. So you can see these are the files I have imported. You can see here. So now I will organize this model and make it as a bracket. So this model with the snapping tool, you can move it to end and scroll it down, and here also the end. So you can see like this, it has been fixed. Similarly, this from center to this center. So this is done. Now select bolt with control left mouse button, press control left mouse button, drag it, release the left mouse button and then release the control. So it's get copied. Again I will show you, press control left mouse button, drag, make it to positive. The arrow with a positive sign should come, not with the negative sign. Drag it to somewhere else. First leave the mouse button and then the control button. If you first release the control button and then mouse button, it will only move, it will not have the copy. So the control button has to, you have to keep pressing the control button and then first release the mouse. Then I will select them again, these delete, this also delete. So now I will select it and the center of this with the center of this. So this is assigned. Similarly, center to this with center to this. So I have assigned these, you can see. Now, as I already mentioned in my earlier video, the selection procedure, if you move it from right to left, all the parts coming in the contact will get selected. But if you move it from right to left, those part comes under completely in the selecting box will come and select. So I will select these only. Then Control C to copy, Control V to paste, so they get duplicated. Then we will click on the translate button here. So it will open the translate and rotate command, and we will translate this to the x-axis, y-axis. Then press shift and move this translating window to the corner of the model, and then I will again select this and move the complete to this end. Now I will select this Y rotation and make it to 180 degree. Then right click to deselect, and so this will get assigned. So in this way you can assign this component. So this is the one way, so you can assign it some other way around. So in this way this is assigned. Now my next point is to assemble the model completely. So if you are not able to see the model browser, press F2 from your keyboard. So you can be able to see, or go to view model browser. So if it's tick, that means you can see. If it's not tick, you cannot see. So I will select the base, press H to hide, the pin, press H to hide, create two more assemblies, left bracket. So I will select these and move it to left bracket. One more assembly, right bracket, and select these and move it to the right bracket. So I'll turn on this and this. I can delete this bolt. So now I have a base, pin, left bracket, right bracket, 4 components. So I can hide this, turn on, turn off this with bolts, turn on, turn off this. So I can assemble, do the assembly like this with once. So these are the options which we can use to create a model in ST Inspire with some basic tools available, and also assemble the model in ST Inspire. So let's start with session 9, that is tutorial 3, sketching and optimizing a bridge. In this lesson you will learn how to use sketch tools, apply support, apply a pressure, apply symmetry, define a design, run optimization, explore, optimize shapes. So we will see these options, how you can use it in ST Inspire 9.5. So this is the GUI of ST Inspire 9.5. To open it, go to Start All Programs, HyperWorks Student Edition version 12.0, SolidThinking Inspire 9.5, and click on Inspire. It will start the GUI of SolidThinking Inspire 9.5. So in this model I am going to optimize a bridge, means I am going to optimize a space to get a proper bridge. So let's start sketching it first. So my first option is to create a rectangle by the corners. So I will have the rectangles with the corner. So from this to this, I will have a 10 centimeter by 30 centimeter bridge. If you are not getting a proper unit system here, just change it from this end. You can change it. I am using CGS unit system. So right click, again right click. So this is the base. I will extrude it to 10 centimeters. 10 centimeters. So I have finalized this box. Now I will cut it down to this edge from this point till this point and somewhere around this point. I want 8 by 6, so I will put it 6 here. Right click, again right click to finalize the shape. Rotate the model and drag it down. So I have cut it the section here. Now I will cut it down some more. So lines, this end to this end, similarly from this end to this end, and I will scoop it down this. So this cut, one more cut. So I have designed a basic shape of the bridge. Then I will create a base of the bridge as in 1 centimeter. So I will have 2 points. select this from this end. So from 2 points, select this, create a new part. We will create a new part here because I don't want this to be in the design space. So I will make a design and non-design space separate. Then rotate the model and for 1 centimeter I drag it down. So this is my bridge. This part I will remove it again. So this is my bridge with part 1 and part 2. We will rename it like bridge and base. Also we will make this as the design space. So this will become the design space. Now I will apply the forces and constraints. So first we will start with the constraints. So this point I will constrain it to all the degrees of freedom. Then this point I will constrain it to only one direction. Then this end we will constrain it to 2 directions, and this end with the same. So I have constrained it. If you are not liking the constraint of the direction here, you can change it, like revolve this to 90 degrees. Revolve this or rotate this again to 90 degrees. So the direction of constraint doesn't matter, but the type of constraint does definitely matter. So whether it is in that direction or that, it hardly matters. But still, if you want, you can rotate it like this, the way I have shown. Now we will apply the pressure. So this icon is used to apply the pressure on the non-design space of 10 bar. So I have applied a pressure of 10 bar on this model. Now I will apply some symmetry, the symmetric constraints on this model. I don't want the symmetry to be in this direction. So I want the symmetry in these 2 directions. So in this way I have completed the deck of creating it. Now as I have completed everything here, so let's solve it. So my model name, let's have a bridge as the name. My objective is to maximize the stiffness. Total percentage of design space volume I want to be 10%, and minimum thickness to be 1.3. Just solve it. Start the solver. It will take a time depending on your system configuration, the type of model you are using. So it takes time to solve your model. So once it gets solved, you can see the results. So is it that it's so simple to get a design? So ST Inspire is definitely help you to have a connection and then get a proper design of it. So where the material is required, where the material is not required, you can know that very easily. So as you can see, my solver has started. So ST Inspire, with the ST Inspire you can have n number of options. Like these are the very simple options, and you can get your model ready as soon as possible. So this will give you a basic idea of design innovation. So if you have any idea of the structure, and if you want to modify it and see how to manufacture the structure and what is the best design for that particular structure, you can definitely use ST Inspire. This will really help you out to get the results quickly as possible. So I will by the time it's solving, I'll show you what are these options available here. So you can see here it is telling me the name of my solver model, then the objective, that is maximize stiffness, then the mass percentage. What is the mass percentage I am restricted to, that is the 10%, so this is showing here, and the first run. So these are the points it's showing. So it's solving. So whatever meshing it requires, it will do the meshing also. It already created the systems and everything. So whatever things required to perform the analysis of optimization, to perform topology optimization like design space, responses, constraints, deconstraints, and objective, everything it creates on the background. So what I'll do is, by the time it's running, I'll export the same file, that is save as. I will save this file or no, not save. I will go to start and export this file in FEM as the model. Why I am doing this is just to show you that how this meshing and everything is done. So to show this, I am doing this. So let's see the run history. So it's been solved. So my model is being solved. I will delete this, I don't want it. So it's still solving, as you can see, and let's import that FEM file. So solver deck, optistruct, model.fem, import. So here you go. I have applied the pressure. So the load collectors, it has already created. It has created some systems to define. Then meshing, it's already done. You can see the meshing is done. It has different components. So I will change the color to get the results better. So these are the different components it created. Design space, it has defined different groups, load step, material, objective, optimization constraints. So it has created everything to perform analysis. So if you see the load step, the SPC and load is already defined here. You can see it. So the 51 and 50 is then the support, as you can see, these are the support constraints. These are the constraints with the card image having all these in one. The pressure. So in Hypermesh, once you open the SolidThinking exported file, you can see everything it created very fast. So within a few steps in ST Inspire, you can solve the model completely in this. So now my result is done. So I will say view now to view the results. So this is the optimized shape which I want. Just click to get into the shape optimizer, and you can have a different shapes. So this shapes look good for me. I will off the supports. So this shapes look good for me. So within few clicks, I have a design space and I have a design to be done. So this is the shape which is best suited for my design. So I can also have a mass, lesser mass. The further things can be done using the evolve to get a better shape. That you can see here, there are some kinks, it's not perfect, so you can use evolve to make it smoother. But now I got a shape which is good, and some material required to withstand the loading I have done. So let's start with the today's session. In today's session, I am going to discuss about tutorial 4, like exploring multiple load cases. In this lesson, we are going to see how to create multiple load cases with unit load in XYZ direction, then create forces and support, apply symmetric planes, apply split draw direction, not a single draw direction, we will apply a split draw direction, then run an optimization and explore the generated shapes. So let's start with opening the GUI of SolidThinking Inspire 9.5. So go to start all programs, as we have already seen. So Altair HyperWorks 12, version 12 student edition, SolidThinking 9.5, and click on Inspire to open the GUI of Inspire. So in this tutorial, let's open the model for this tutorial. We will see the model of Y bracket. So this is the model. So this one is boss and this is the bracket. So let's make the bracket a design space. So now this bracket is a design space, as you can see. If you are not able to see this model browser, press F2 from your keyboard. So F2 will help you to turn on and off this model browser. Now, first step is to make this as the design space. Then the next step is to make the unit system as SI unit system. So first we have to make this as the design space, and then we have to make this as the unit system default SI unit system. So turn it on to SI unit system. Now let's create the constraints. So I am going to constrain it for all the degrees of freedom. So you can see it has created all loads and displacement. Load case 1, so we will rename it as load case X. Then apply the forces here, X direction positive, here X direction positive. So these two forces I have applied in X direction. Now I will turn off these forces. Go to load case X and create one more load collector as load case as load case Y. And just right click here, click include in load case Y. So I will, instead of creating the constraint again, I can just include the same constraint here and apply the forces. So click here Y negative, click here Y negative. So I have applied the constraints in Y direction, the negative Y direction, with a unit load collector. Again the same for load collector Z. Sorry. And you can use the drag and drop option, so it will get included here, and create the load Z axis positive. So now let's open all these. So just click on show on, so you can see the load collectors in all the three directions. Now this is done, the forcing is done. Now I will apply the symmetry for this along these two planes. So I want the symmetry in these two planes and a draw direction, a split draw direction along this axis. Along this plane I want a split draw direction. So we will have a different options, like if you double click here you can have no holes and holes. So if I press here it will not create holes, but if I turn off this it may create the holes during the splitting. So I will explain you all these. So one by one I will explain all this what are the different formats. So we are going to solve these different load cases. Like load case X only, we will see the results. If we apply only load case X, only load case Y, only load case Z, then we will see the results when we apply all the load cases at once. In the similar way, you can have a couple of load cases, then one with a load case, one with load case having a split draw direction, no holes option deactivated, no holes option activated, and load case with some change in the shape. We will see all them. So let's start one by one. I will change the name as load case X only. Maximize the stiffness. Total design space I will have 30 as the design space, and minimum thickness constraint is 0.015, and keeping all the other parameters as it is, just press on run. So we'll start solving the first load case. It takes time to solve or run the analysis because it does the meshing and everything. So please wait for some time till it's solving. So by the time it's solving, I will have all the others. So that is the combined one. I will rename it again. So this is for you have to just go to load case and take only load case X, run. I will rename it. Once it's done, I will rename it again. Then Y, run. So keeping all the parameters as it is, I am applying the solver one by one. So of this Z only, and run. So these are the 3 runs. The first one is the combined one. So I will rename it again. Then I will first one is with no holes activated, and then deactivated, then I will activate it, and load case COM combine no hole activated for all the load cases, run. And then some changes in the shape. Let's see. So what I'll do is I will hide these shape controls once, and go to push pull, and make it to 0.7. Similarly, change the shape little bit here also. I will activate this, and as this is not a symmetry no more, so what I will do is I will activate this and turn this off. So I will have the symmetry along this. So one more load case, I will change this to no holes. One more load case, combine, shape change, and run. So now you can have a parallel solving, so it will solve all the load cases, just you can have to put it back to back. But the point is this should have a good machine to solve these back to back load cases, and also give a power backup, because if it's shut down, so it may crash down. So the machine should not get shut it down, because you cannot restore the run because it's solving. Okay, so you can have a back-to-back run, but you cannot have when the machine is not good. So I have applied all these solvers, so it will solve, and it takes some time to solve. So I'll pause the recording till that it's solving. So these are the different load cases which I'm going to solve. These are the two with the shape change, and these are the others. So once they get solved, you will see the results. You can see it has solved one. So we'll wait for some more time till that it's solve all the others. Now you can see that it has solved all the load cases. Only one is left here now. So within a couple of seconds, this will get also solved. So now you can see that all of them are being solved. So we can see the results. So these are the results. This is the main bracket. So this is the second result, then the third, fourth, fifth with no holes. You can see that the result it has given with the no holes option, and the shape change. So the first one is combined loading for X, for Y, because of Z, the shape, with no holes option, combined loading, and the shape change. So we can modify the design here like this. So if we change the shape, this type of design we will get. So you can get these many designs in as fast as like solving anything. So you can use ST Inspire to get a design for multiple load cases, solving them at once. So in today's session, we will going to see how to import a CAD model, break a part into multiple parts, copy reference geometry, trace curves using sketch tools, pull a sketch curve into a solid, use Boolean intersection to create new parts, define a design space. So in today's session, what we are going to do is, if we have a CAD geometry and we want to divide it into design and non-design parts, so how you can do it in ST Inspire 9.5. So let's start with the opening of GUI of SolidThinking Inspire 9.5. In short, it's called as ST Inspire 9.5. To open it, go to Start, All Programs, Altair HyperWorks Student Edition, SolidThinking Inspire 9.5. Click on Inspire. It will open the GUI of SolidThinking Inspire 9.5. We'll open the model as armstraight.x_t. So this is my model, as you can see. This is a single part. So if you want to perform the topology optimization here, or perform optimization on this model, we need to divide the part into design and non-design space. So how you can do it, we'll see in this model. So we will start with this sketching tool. So we'll use the break, create new part, click on create new part, then click on this line and select create curves from all reference lines. So it will create an entire curve here for the new part. Then right click to select this part, again right click to finalize it. So we have created a reference surface of this. So what I'll do is I'll turn off this. So this is the reference surface. Now I will use push pull option and pull it the other way around. So I have pulled it this way and on this. So now I have two parts. One is this part and the other one is this. So now I am going to divide this part. So to divide it, we'll use intersect option. Select this part, select the other part, turn on keep this and click on perform this. So this will now become the new part, you can see here. So you can rename it as paddle. We will rename it as paddle. Then this also will be a non-design space. So to create this, again go to break, select, create new part. But we don't want this to be the reference line. So what I will do is, I will right click on the edge and click on create curves. So I will select the curves which I want the surface to have like that. So I have this curve, again right click. So I have a new part with this. So now what I will do is, I will turn off this one and go to push pull and pull it down. Turn on the other. Again go to intersect option, select the base part, the other part with which I want to intersect, and keep this part and click on perform the operation. So now I have this as a separate for the non-design. So I have these two separate non-design components, and this is one component. Also this I want to divide it. So one more option we have to divide it is, we can create a circle, create new part. From this center to this I will create a circle. So I have created a circle in the new part, you can see. Now I will turn off this, off and off. Now go to push pull and pull it down, turn on the other component, same intersection option, select this part and click on perform the operation. So now I will turn these on. So now I have these three as a different components. So these three will be a different component which I can take as the non-design component. So I will right click and make this design. So in this way you can edit a CAD geometry to make it in a design and non-design space. So whatever CAD geometry you have, once you import it, it may occur that it comes in one part or multiple parts. So if you want to make a certain sections of design and non-design, you can use these commands to perform these operations. So in today's session I am going to show you how to remove rounds, fillets and pockets using push pull tool. Then sketch on existing geometry to create a new part, copy and move a part, join parts using Boolean combine tool, and split parts using Boolean intersection tool. So we will see these options which help us to defeature a model of existing CAD geometry. So let's start with the SolidThinking Inspire 9.5. I quickly show you how to open it. Go to start all programs, Hyperworks Student Edition, SolidThinking 9.5 and Inspire. Once you click on Inspire, you can it will open a GUI of SolidThinking Inspire 9.5. So let's open the model. Push pull bracket. So this is my model which I want to on which I am going to perform the CAD modification. So geometry modification I will do. So if I want to remove these fillets, how I can do these, and these pockets, the below pocket I want to remove, how can I do it? If I want to change this L brackets, so how I can change these brackets, and if I want to split this base into two, so that my bracket will become the one design component and the base will become the non-design component. So let's start with the push pull, removing this. So you can drag it in this way to remove this, or you can simply put 0 to remove this. So click 0. So click on the curved surface, and whatever radius it's showing, just put 0. So it doesn't depend on the which unit system you are using. You can just put 0, and similarly select these. So I am removing all the fillets of this geometry. So 0. Similarly this one 0. So it's very simple in ST Inspire 9.5 to remove the fillets. So in this way I have removed the fillets, as you can see. Now the next step is I will remove these pockets. How I can remove this pocket is, like, I can push it to this, and I can push this to this. So I can remove this. Similarly at the bottom also, from here to here I can push it. So using push pull options you can edit the geometry, as you can see. Now I will show you some more options that if I want to increase the thickness of these components, these L brackets, how can I do that? So I'll use the same bracket and use this to intersect it to the midpoint. So it's taking the other one. So what I'll do is I'll put this to this extent, change it a little bit, and then again drag it from this to this. So it has to get the line properly. So this end to this end. Similarly from here to here, then from here till here. So I can change the dimensions of existing geometry also. Now if I want to add a surface on this, so how can I add a surface? So go to the sketch rectangle option, select the surface, create a new part. From this bottom to this I want to sketch a geometry. Then same push pull command. Similarly here also push pull command. So I have created a square bracket here. Then select, simply just copy and paste it. Select this end and drag it to this end. So in this way you can modify this geometry, but this is 3 different parts. So what I will do is I will go to combine, select these parts and combine this. So now this will become a one part. One more thing, you can see here that we have one bolt here but no other bolts here. So what I will do is I will just copy, paste, drag from here to here, then again I can move it to this. Similarly this and this I will select 2, then copy these 2, paste these 2 and take the center from these and align it to this center. So I have added the bolts for all, you can see here. So editing the geometry in ST Inspire is very simple. You can move the parts and sketch the geometry. Now if I want to split this base, so I can also do that. Select the surface, create a new part. Then from this end to this end, I will create a right triangle. Then mask all, only highlight this. Push pull the surface, unmask all. Then I will use the Boolean intersect option if it's unticked. So I will first select this complete bracket, intersect with this bottom bracket, and keep the original. So the keep original this I will on this and just click on play. So now I have this as a different, this as different. So I'll make this to design space. So I have now a design space, a non-design space separate. So these are the options which you can do in ST Inspire to divide the model into design and non-design space, and modify the model also. So you can modify your CAD geometry in ST Inspire according to your requirement. So today we are going to see running and optimizing optimization with an objective of minimizing mass, then applying an extrusion shape control, then applying stress constraints, applying displacement constraints, and evaluating the results of optimization. So let's start with the opening of ST Inspire 9.5. To open SolidThinking Inspire 9.5, go to Start, All Program, HyperWorks Student Edition, SolidThinking 9.5, and click on Inspire. We'll open the model, rear set bracket. This is a model in which the loading of standing, as you can see, is already applied, and also the loading of braking is already applied. So you can see the different loading cases is already applied on this. Now we will apply the extrusion constraint on this. So I have applied the extrusion constraint on this. Now I will solve the model for minimizing the mass with a factor of safety 1.2 and the thickness constraint to be 9 mm, solving for both the load cases. So we will solve this first load case, and in the later portion of the session we will see how to apply the different constraints and view the results. So now you can see it has been solved, the first load case. So you can see the results. So what I will do, I will always see the results in the second last option and save the different shapes, and then it will be easy for me to compare the results. So I will save this first shape, creating a new folder, shapes, then shape 1. Now I will solve this same model for the factor of safety 2 without changing anything. I will solve the same model for the factor of safety 2 and see the results. So you can see I have got the second results for the safety factor 2. So I will move it to the second last option and cut down the results, save it as shape 2. Now I will see the design violation. If you put bigger factor of safety, then what happened? So let's see that. Now we will solve it for the higher factor of safety to get a. So whether for this loading condition, for both the loading condition, whether we can achieve this factor of safety by removing the material or not, or minimizing the mass or not, we can see now. So you can see it has given an error. So we will view this error now. So just click on this and it is showing an error that design violation. So if you click on this design violation, the message dialog box appears with which error. For the displacement constraint, the error is giving stress constraint, mass target, frequency constraint. For what constraint the error is coming, so you can see it is giving the error for the factor of safety 4. So it is not for this model, it is not possible to achieve this factor of safety. Now I will apply a design constraint on this. So I will apply the design constraint on this point for the displacement not more than 0.6 for all the degrees of freedom, and I want this displacement constraint on standing load case. So I want this displacement constraint on the standing load case. Now again I will solve this for the factor of safety 1.2 for on both the load case with a design constraint activated. So now I have constrained this to displacement of 0.6, so it will not move more than 0.6. So apart from the design stress constraint, I have applied one more constraint as the design constraint. So these are the different constraints which you can apply and get the results. So it has solved this. I will view the results for the second last. So I will again cut this shape and save it to shape 3. So now I have the results for a factor of safety 1.2 and minimum displacement constraint, minimizing the mass with a factor of safety 1.2. So now we will see the results. So if I open this, you can see this is the first result. So these are the two different results, one without displacement constraint and one with displacement constraint. So these are the different shapes which you get by providing different constraints and different factor of safety for the same results. So in this way you can solve your model and get the proper and required shapes. So in today's session we are going to see how to save optimized shape of the how to save an optimized shape to an STL file, and how to export the optimized shape to evolve, so that we can modify the optimized shape, or we can smoothen the optimized shape to get a better shape for as per the manufacturability, and also evolve help us to render that optimized shape. So let's open ST Inspire. I will use the previous file. So go to history and open any one file, any one file, just open it. So this is the file. I will have a better shape like this. So now this is my file. I will hide the load cases. Now what I will do is select all the files, all the shapes, go to file, save selected, and from the drop box I will select STL file and save the model. So I have saved this model. Similarly for STL file, so now I will export this to evolve. So just select again, right click, click on save to evolve. Once you click on save to evolve, the model will get saved to evolve. Now open evolve, go to start all programs, HyperWorks Student Edition, SolidThinking Inspire 9.5, and click on evolve. Once the evolve get opened, select generate shape. In that, click on optimization shape browser, select this shape. So now you can see the optimized shape which we have finalized there is being imported on the Inspire file. So this is the shape. Now from evolve you can modify your geometry to get a proper and smooth shape. So evolve help us to provide you the smooth and proper shape for that. Now I'll again go back to Inspire and open that STL file. So now you can see I have a one model in Inspire. So where I have the material and other properties. So in this way you can save the file in Inspire, and also you can export the file to Evolve using these two options and modify it. To know more about Evolve, you can use help or go to the next training series of SolidThinking Evolve 9.5. So you can proceed to the next training series. So in this way I have ended with this training session. So this was my last training session of SolidThinking Inspire 9.5. If you have any queries regarding the SolidThinking Inspire 9.5, feel free to contact. If you have any feedback regarding the training series, your feedback is very precious. Please put your feedback also. Thank you very much for attending this session or watching this video. Have a great day ahead.